name is Dr. Jeff Rutledge. I'm the Chief Medical Officer at HealthTap, and I'm delighted today to discuss how the latest AI technologies are being applied in healthcare. In particular, we'll go through some of the examples of how AI is actually being applied in the real world today. And I'm going to describe the next generation of what's possible to do that we're actually doing now at HealthTap, the virtual physician assistant. You know, there are nearly limitless opportunities for the latest generation of AI technologies to improve the way we deliver healthcare. And as I say, it's already being used to streamline administrative and documentation tasks. The next step will be to use the intelligence and the capabilities and the knowledge of the large language models and the newest AI technologies to actually improve the clinical decision process and support better healthcare that doctors deliver. I want to take a step back and describe how, as a company, HealthTap is focused on primary care. And the reason for that is that primary care is incredibly important. People benefit from having a primary care doctor, and more primary care results in better outcomes for patients. They get more preventive care, and they actually live longer. The interesting and exciting application of generative AI in the form of a virtual physician assistant means that we'll be able to expand and improve the effectiveness and reach of primary care physicians. But I want to take a moment to step back and discuss how we got to where we are, what kinds of AI technologies preceded the current generation, and how they have led to the applications of AI in medicine. You know, we've had AI in medicine applied since the early 1960s. In fact, the very earliest applications of the early forms of AI, the so-called expert systems that were based on production rules, occurred in medicine. A program called MYCIN demonstrated expert level performance back in the 70s as a first demonstration of the powerful impact that AI could have on healthcare. There have been a variety of other technologies, from Bayesian reasoning and causal probabilistic models to other forms of machine learning and to neural networks, applied again in many cases to healthcare. The early neural networks from the 1980s and 90s were relatively simple networks because we didn't have the kind of computing power that's available today. What we've seen in the last 1.5 decades or so has been the evolution of much more complicated neural networks. So-called deep neural networks are multi-layered, large aggregations of neural networks, which allow the training of much more sophisticated data to create so-called large language models. The latest generation of generative AI is based on something called a transformer architecture that was first proposed in 2017. A team at Google Brain demonstrated that transformer architecture could be used to organize these complicated neural networks to create large language models. The so-called generative pre-trained transformers, or GPT, are now able to create an interactive dialogue based on the large language models that are built into them. The GPT is a large device or a large network. In fact, they are some of the largest computing structures ever created. The latest iteration of ChatGPT, number 4, in fact, has more than 1 trillion parameters inside it. And these large language models require enormous computing resources to train. In fact, one training cycle for ChatGPT was said to require more than $2 million in computing time and cost from electricity use of these devices. In fact, the OpenAI is said to have deployed more than 30,000 different GPUs in an effort to train these models. And those GPUs have a daily electricity cost of about $50,000 and require months of time to fully train the network on all available data. So ChatGPT is a general purpose large language model, and is of general nature in that it is trained with literally everything that can be found, and it's available in text form to participate in this unsupervised training process. Other medical large language models are under development now. Notably at Google, MedPom 2 is available, and it's been trained more specifically on professional, trusted medical resources. although it's smaller than the larger ChatGPT. And frankly, to date, the medical large language models have not yet demonstrated improved performance compared to the larger model. One of the challenges of these generative AI methods is that it's possible for them to make stuff up. They can so-called hallucinate, or more accurately, confabulate information where they say things that simply are not true. The bottom line is the outputs of these generative models cannot be considered to be more reliable than the training data. And when the training data itself are not trusted or completely known to be accurate, it's possible for the output to similarly reflect inaccuracies in the training data. Because of this concern, one of the questions we had when ChatGPT was first released was, how suitable would it be for answering consumer health questions? And more importantly, how often would it hallucinate or make things up and give answers that were factually incorrect? One of the things we did at HealthTap was take some of the questions that had been asked, consumer health questions that were already answered by doctors, and ask the question, well, how would ChatGPT be able to answer those very same questions? We then had the answers to those questions reviewed by a large panel of doctors. We had more than 10 doctors review each question answer pair and evaluate whether the doctor's answers to a question were in error or good or great, and similarly, whether the ChatGPT answers to those questions were in error, good, or great. And interestingly, what we found was even the earlier version of ChatGPT 3.5, which was end of last year, 2022, that even that system had an error rate that was very comparable to the error rate that doctors had, as judged by other doctors. But interestingly, they were more successful at creating good or great answers than the doctors were. ChatGPT was less likely to be incomplete in its answers and more likely to give an answer that was judged to be great, as in complete, thorough, and helpful in its effort. So what we demonstrated is that the current generation of ChatGPT is actually doing a pretty good job at answering typical health questions that people ask. We may also say, well, how is generative AI being used in primary care today? And the answer is there are already applications that are in place today that are being helpful. These applications are improving efficiency of healthcare by reducing the time it takes to complete tasks that doctors would normally take. So, for example, ChatGPT can be quite good, and other GPT models can be quite good at summarizing health data. So where data are available in an electronic system, rather than having the doctor review in detail all of the prior notes, a summary of those notes can be created quite efficiently and effectively by current GPT technology. Such technologies can also be applied to improve the billing coding and claim submission for doctors. It can also be used for writing letters. Referral letters and prior authorization requests are both well done by a current generation of GPT, taking a process that would otherwise take manual effort and improving its efficiency. I'm more excited by the current experiments underway that are deployed already, where using ambient listening technology, where listening to a doctor's conversation with the patient at the time of a visit, it's possible now to take the transcription of that audio and feed it to ChatGPT or other large language models to create actual clinical notes on behalf of the doctor. This greatly frees up the doctor and reduces one of the administrative burdens doctors have in documenting their encounters. And so this is another method of using AI to create greater efficiencies in delivering healthcare. I would note, though, that each of those applications improves efficiency without really changing what the underlying healthcare is. The underlying healthcare is made more efficient and may cost less as a result, but it doesn't change what care is delivered. I'm very excited by the next generation of what's possible to do, leveraging the medical knowledge that is found inside these large language models in the form of a virtual physician assistant. The idea of a virtual physician assistant is that the system, we call our system Dr. AI, functioning as a virtual physician assistant, can perform a medical interview. So this can be done before a scheduled visit in a virtual primary care setting, where the patient is interacting with a chat agent, which asks questions that amount to taking the medical history. So we literally ask the large language model, what would the doctor ask next? And do that repeatedly, listening to the answer each time, allowing people to type free form their answer to the questions that were asked to the patient. Once the system finishes asking questions that are relevant to the patient's problem, the large language model can create an entire clinical note for the doctor in draft form for the doctor to use. What that means is that when the visit starts, the doctor can rapidly read a summary of all the common questions and the ordinary things that a patient would be asked as a result of their clinical presentation. Interestingly, after that, the language model can also offer a differential diagnosis. Now, we don't consider this a diagnosis for the patient. What it is a tickle list or a prompt for the doctor to review and make sure the doctor's thought through each of the different possible explanations for the symptoms the patient has. We've demonstrated previously that when you show doctors lists of differential diagnosis for a clinical scenario, their diagnostic accuracy increases significantly. So we're looking forward to this process of improving and supporting the clinical decision-making that doctors have. I can show an example of that. This is a real example of an actual patient who presented on HealthTap, and using the answers from their interactions, we can show how the ChatGPT and Dr. AI virtual physician assistant works. The patient engages initially with the AI in the form of a chat interaction, and the questions are asked. The Dr. AI gives supportive responses and asks next questions in an understanding way, listening thoughtfully to each of the answers that a patient gives. And after completing the interview, then Dr. AI is able to present a draft of the note that the doctor would then be able to read, edit, and complete. Remember, the doctor is now able to spend more time delving into the things that are uniquely human that only a doctor can do with their patient. They're able to confirm, review, and confirm, and be reminded of all of the things they should think of in evaluating their patient. So we're very excited at this next generation of AI as it applies to improving the performance, effectiveness, and reach of primary care in America.